The principle of superposition explains what happens when two or more waves meet and overlap. The displacement at any given point is the combined effect of each of the two waves' individual displacements, added together as a vector sum. This means we take both the size and direction of each wave's displacement into account. The principle is universal and applies to all kinds of waves you might encounter, like sound waves, light waves, and water waves. Importantly, once the waves have passed through each other, they don't change. They continue on with their original properties intact. This interaction is temporary and does not permanently affect the individual waves.
When two waves meet while their crests align, this is called constructive interference. In this case, the waves are in phase, meaning their individual displacements line up in the same direction and combine. As a result, the waves reinforce each other and produce a wave with a larger amplitude than either one alone. This maximum reinforcement happens when the phase difference between the waves is 0, or any multiple of 2 pi. You can see this in the diagrams where two pulses approach, overlap to form a taller pulse, and then move apart again.
When two waves overlap and are out of phase, meaning a crest meets a trough, destructive interference happens. This occurs because their individual displacements are in opposite directions and effectively subtract from each other. As a result, the combined wave has a smaller amplitude than either of the original waves. In cases where the waves have the same amplitude and are exactly 180 degrees out of phase, they completely cancel each other out, resulting in total cancellation. The illustrations show two pulses approaching, then overlapping and canceling, and finally moving apart again with their original shapes intact. Here, we apply the principle of superposition by adding the vertical displacements of two different waves at each point along the horizontal axis. You can see the yellow and blue waves represent the original waves, and their vertical values are combined point by point to create the red waveform. This red line shows the resulting complex wave formed by the continuous interference of the two source waves. Understanding this method helps us analyze how more complicated waveforms arise, which is essential for grasping concepts like beats and standing waves.